Hello and welcome to another episode of our post cloud podcast. This week, we are going to be talking with a guest, Adrian, who's going to be talking to us about building secure container images, security within software and in the containers, and so on and so forth. So it's going to be an interesting conversation today, and our first guest, which is exciting. My name is Chris Krantz. I've been doing cloud and cloud technologies for a number of years now, joined by my co host, Stephen.
Hello, I've been infrastructure engineer and solution architect for a few years looking at cloud and on-site compute. And Adrian, our first guest, would you like to introduce yourself, Adrian?
Hi there. I'm very honoured to be the first guest. Yeah. My name's Adrian Mouat. I'm currently technical community advocate, or DevRel if you like, at Chainguard. But yeah, I've done a lot of things in the past, some software engineering, a lot of stuff around Docker and containers, and I'm still a Docker captain. Yeah, plenty of things related to cloud, I guess.
Awesome.
Awesome.
Let's jump in and talk about container security.
So, Adrian, I thought containers solved all our security problems, and when we moved from VMs to containers, we magically had everything secured.
Yeah, I kind of wish they did. I guess in a lot of ways, or in some ways, you can argue VMs are more secure because they have the extra sort of virtualization layer. But what containers give us is isolation. So you sort of hope if something goes wrong and an attacker gets into a container, they can't attack other containers. So by themselves, hopefully, containers do add a certain amount of security, but there are still plenty of problems. We can never solve application security, right? You always need whoever's writing your applications to keep security in mind and adhere to security best practices, or you're going to have problems. And same with your ops team. That being said, one of the things we do at Chainguard is supply chain security. One thing we're very fixated on is vulnerability scanning. So that's tools like Sneak and Trivy and Gripe, and there's a lot of other ones as well, where you can take a container image or quite often like a binary or software artifact, and you can scan it, and they will tell you about known CVEs and that. And if you scan like a lot of container images on the Docker Hub today, you're going to find there's a lot of vulnerabilities in them. And we basically supply container images for common applications and languages, etc., with low to zero CVEs.
I've worked with a few of those container specific vulnerability scanners in the past. And yeah, the challenge is definitely you get a lot of information. And then knowing where to start is a big challenge. And sometimes it can be quite overwhelming to the point where if everything's a priority, nothing becomes a priority, as they say. So I guess you're fixing that underneath that. So you've got all these vulnerabilities. Normally, how do people then go from, okay, I'm using Ubuntu base image, I've got my application installed, and all these vulnerabilities. I've seen Chainguard images, I've seen Wolfie. What's the step? What's the process to then move that across? How do people adopt that?
In the best case scenarios, it's trivial. So like if you're using say Redis or Nginx or something like that, well, we have a Redis and Nginx image. So if you're lucky, you can just change the from line in a Docker file and it'll just work, or change the image in your Kubernetes YAML and it'll just work. That might not always be the case. One thing to be aware of is our production images are distroless, which means they're really minimal. We keep like the sort of minimal amount of software in a container that's required to run your application, and its dependencies and nothing else. So typically our images don't even have like a shell or package manager in them. We do have sort of dev images that do have that for debugging and development purposes, but our run and production images are really stripped down. So sometimes that means you might find you've got to do a little bit of work to get your application or your Kubernetes configs working with that. But in the best case scenario, it's just change a single line of code.
You say your images are distroless. I've seen a few security scanners rely on having some form of distro and package manager in there in order to understand what's in the container. Does that mean there's certain kind of prereqs as to your packages working, your containers working with certain vulnerability scanners and security engines?
We have our own Linux distribution called Wolfie. Now, you're absolutely right. That's exactly what scanners do. Basically, a scanner or majority of scanners will go and ask, like the Debian database inside the container, that apt has a list of all the packages that are installed in the container. In Alpine, it's APK, and it'll give you a list of all the packages installed, etc. And that has some interesting side effects. You will find, like, say I use a scratch image and I copy a completely static binary into that. Um, that will run and that will work. And some scanners will not be able to find any software in that because there's no package database to look at. There's no APT, there's no APK. And so it doesn't work. Now that's not all scanners. Some scanners, like say it's a Go binary, they will be able to pick up the metadata in the binary and tell you information. But you're absolutely right in what you said. So in our case, we have our own Linux distribution called Wolfie. So our images do come with like a database in the APK format.
I think a lot of people just grab whatever's off the shelf without really having the context.
The major thing is, people realized they were using like the Ubuntu, the Debian, etc. image, and you would build your program inside that container, and then ship it and run it. And the thing was, in that container, you then didn't just have your program. You quite often had the compiler that was used to compile it, all the various utilities within the distribution as well. So, your LSs, your makeDARs, your Cheons, including ones with the elevated privileges. Ping has elevated privileges, for example. So we were at one point, we were at this point where all these things were in the container images that were even running in production. And people started saying, well, I don't really need, these binaries that have elevated privileges. Can we get rid of those? And you'll find that most of the distributions, cut down on that a lot, or into containers, in container base images. And then people started thinking, well, actually, why do I have my compiler? I don't need to ship my compiler to production. And then we got multi-stage builds from Docker, and that was a huge improvement. So what you did then was you built your product in one stage, and you copied the application out into like another image for the runtime. So a typical example is like with Java, you'll build your Java jar in a JDK image, but you'll copy the jar into a JRE image for running. So you don't have all the weight of the full JDK, for example. So there was a sort of trajectory there. So Dan Lawrence and Matt Moore, two of the founders at Chainguard, were working at Google, and they started this distroless project. Basically, they wanted to take it to an extreme and see how much you could pull out of a distribution and still have something usable. Because your first thought might be, well, can't I just take it to the extreme of having this scratch image and running my applications in a scratch image? And you can, in some cases. So, for example, I can create a static Go binary, put that into a scratch image, and run it. But if I try and do something like talk to a website, it won't work because you don't have TLS certificates. If I try to create a temporary file, that won't work because you don't have a temporary directory. If I try to do something in users, that won't work because you don't have a home directory. So there are certain things that are sort of expected by most applications to exist within a container or an operating system, I guess. And that's exactly what distroless is. It gives you the absolute minimum required to run the average application. And so once we got there, then we had a point where we sort of figured out the absolute minimum we could put in a container, and I think that really helped. So that was the kind of trajectory we were on. But even at that Google distroless level, they only had images, and they still only have images for a handful of things. So there's like a Google distroless image for static binaries. There's a Google distroless image for Java and Python, but that's about it. So with Chainguard, we were like, well, hang on, what about other ecosystems? But not just that, what about applications? Right? Why can't I easily get a distroless image for Nginx and Redis and so on? And that's exactly what Chainguard did. And we did do things in rather different ways. So I think Google distroless uses Bazel. We actually built our own tools for creating images. So we have something called APKO, which takes a bunch of APK files and assembles them into a container image. And that's all it does. So you can't even, with APKO, you can't even add in arbitrary files. They have to have your files inside an APK already. So it's a very simple build tool compared to Bazel and compared to Docker build. It can't do a fraction of the things that either of those can do, but the payoff is that it's much simpler. So it's fast, and it can produce distroless images. So the problem with Docker build is that you have your run statement. So you kind of need a shell and a package manager inside the image you're building. But with APKO, the assembling of the image is done outside, if you like.
Are you seeing kind of customers and end users building their own distroless or minimal images and with success?
We have seen people use our tools. So we have AppCo that I've just talked about. We also have Melange, which is what we use to build our APKs. But generally, for most people, that's not what I'd advise. AppCo is very much, we've built it for our own needs. So for most people, what I would suggest is use Docker build and use a multi-stage build, but use our images as the base. So what you're going to do is do your regular Go compile or build your jars in your normal Java image or your Ruby image or whatever, and then copy them into a distroless base.
You mentioned APKs there, so that's packages from Alpine Linux.
So Ariadne Connell was a lead engineer at Chainguard, and she did a fantastic job. But she has a background in Alpine, and that's why we use the APK format. So we use APK format, but we have our own Linux distribution called Wolfie. So like to get this all working, we had to come up with our own Linux distribution, which sounds crazy, and I guess it was, but yeah, that's what we did. And there's several reasons we had to come up with our own Linux distribution. But just to be clear, we use the APK packaging format from Alpine. We actually have our own tools to build APKs though, and we compile everything from source in Wolfie. So it's a completely separate distribution to Alpine, and everything's actually compiled against glibc in Wolfie. So it's completely incompatible with Alpine. You can't mix and match Wolfie and Alpine APKs.
So just a handy format that one of your staff had on hand, and off you went.
Yeah, I mean, to be honest, without Ariadne knowing all the intricacies of how to build, a Linux distribution from working with Alpine, I think we'd really have struggled.
I wonder going forward how much OS builds are going to become a toolkit as much as application builds. It feels like there's more and more reason to have operating system toolkits and skills to build operating systems on hand. They're becoming more exposed to application users than they have been in previous generations of apps.
Yeah, and also with the OCI format. So I mean, the OCI format really is you can compare it to your ISOs and so on. It really is an operating system file system and not much else. But it's nice having that format that you can target, and that allows the creation of tools to target that format.
I'm old enough that I remember there being an operating system team and an application team, and they weren't even just separate teams, they were separate types of people, really. Like the operating system team were not typically software developers. There may be a few thrown in there, but they were by and large a group of people who'd gone on training courses relevant to that specific OS, whatever the flavor was, whether it was Red Hat or might have been Windows or Solaris or something. And they had niche skills just in that OS. But increasingly, everyone's using Linux, and you're not drawing hard lines between Ubuntu and Red Hat. And you're considering more and more, well, how is an operating system comprised? What are those expectations? And you were talking a little while ago about, well, there's some generalized expectations that applications look for in an operating system, a Linux-based operating system. Where do I get temporary files? Where are user directories located? How do I execute these common operations? So is it more about meeting those expectations as an application developer? And are you looking at things like Linux standard base as an application developer?
This also gets into like a topic I love, but it's never come to fruition, which is the whole unikernel idea, which is where you sort of combined the operating system and application into a single object, or the kernel and the application into a single object for a sort of really minimal and secure approach. I don't know. I mean, we're also kind of getting into DevOps here, right? Because what do you want your application programmers to think about? And what do you want your ops teams to think about? And how much do you want them to talk to each other? I think that's what it really gets into.
I guess the concept of the unikernel, how does that is that it kind of has similarities with building eBPF applications? Are they kind of solving the same problem in a different way, or is that completely different concept?
The Linux kernel is basically how you talk to the hardware, if you like, how you make files and sockets and so on happen. Um, so if you combine that with the application and you have a single binary that's your kernel and your application, which is what we kind of used to do back in the days of Atari STs and so on. If you think about it, your application would have been responsible for talking directly to the hardware. Um, Yeah, basically, if you combine those two, there are arguably security benefits, and you end up with a VM image that can run directly on AWS or somewhere, but it's only runs a single application, and there's only but one thing in it, if you like.
They seem to be a great compromise where you got the speed of a container and that fast startup, but then you've got security benefits of having a virtual machine. But for some reason, that it never quite got momentum. I wonder what happened to that concept overall. Was it just not easy to absorb? Was there not enough people who saw the value in it?
I think the real reason, well, there's sort of two reasons that go hand in hand why it never took off. One, because it's not necessarily easy to build um, unikernels. There's a few different approaches, like rump kernels and so on, and it was kind of too niche to roll out to production. And the other thing is the benefits are a little bit intangible. Like we can talk about security benefits, but nobody else is doing it. Why would I do it? Because it's just something that's might never help me, or might never. It's not going to help my boss, right?
And this is the big problem. Security is seen as something that just magically happens, but yet no one is actually responsible for it and it'll just take care of itself.
Security doesn't bring in revenue. By WhatsApp releasing more security in the product, more people aren't going to use WhatsApp. By whatever application you've got, if you release more security, the average person walking down the street doesn't turn around and say, "Oh, that bank has got this new security feature. I'm going to choose them over my current bank." Just not going to happen. If they turn around and say, "Oh, I've got a free credit check or something that's going to help me reduce my spending," that's an actual feature that's going to benefit their lives, and they will choose that. So it's security just isn't a revenue for most people. There are obviously security companies, Chainguard and so on, where it absolutely is a revenue generating thing. But for the most people, it's not a revenue generating feature.
In a marketplace that is functioning as a marketplace, which is where there's more than one stall where you can buy stuff, what you can have is a vast amount of reputational damage to a company, effectively smearing the company name. And that is a cost. That's a very real cost that you can get from security. And I think the trouble is people don't connect that back to an overall balance sheet.
But going back to the point you were making before, which I think was absolutely right, is that if you add more security or we invest in security, the best thing to happen is that nothing happens. And that's not the same with features, right? If I build a new feature, I can point at it and people say, "Oh, that's a great new feature, I'll use it." But that's not what happens with security. Like literally nothing happens. You might have avoided an attack. That might have cost you millions, but it's all might.
We're also shipping much smaller images because we're secure. So security often improves agility, and security improves the rapid delivery and stability of a service for its users. Because if you're doing security updates, you tend to be doing bug fix updates as well. So overall, that user experience metric should be going up and up.
And I guess it's worth pointing out there are benchmarks and things like that you can point at, and things like salsa. So there are things you can point at and say, "Hey, I'm doing this," which is a little bit like a gold star for security. I guess most important things to have a security mindset rather than to achieve any particular goal. And I think that's what can be hard to instill. The organizations that have the worst security are going to be your large um, enterprises with like tens of thousands of employees, which are not historically IT companies, but of course every company's an IT company now.
So we've talked a lot about the build side of building those images and having secure image base images. But I guess that's half the picture, and it's something we've talked about before with Kubernetes in terms of that building is one thing, operating is another. I'm guessing those images, the vulnerabilities in those images aren't static. They don't stay still. You've still got a process of coming back and revisiting that one. And I feel like that's something that a lot of people get wrong or struggle with. Any recommendations or observations from you on that, Adrian?
It kind of ties into actually what I sometimes talk about, which is how our images have zero known vulnerabilities. And it's threefold, I guess. But one, we have minimal images, which we've talked about. But the second point is we keep things up to date very aggressively. So we have a bunch of automation in place that tells us when a project has released a new version. So within like 4 hours or some of a project doing a release, we've normally got that new version packaged up, and then a little bit later we'll have the container image out as well. So we try to keep things absolutely up to date, and I think that's a key point for most organizations, is try to keep your software and your dependencies up to date as possible. Now that's not easy because you update things and things break. So you've got a constant investment and effort going on there to try and keep things up to date. At Google, they sometimes talk about build horizon. So yeah, I work with a bunch of people that are ex-Google, and they told me about this. But basically, at Google, if a container or a VM or whatever is running in production, it automatically gets taken down after a week or so and rebuilt and redeployed. Because the thing is, even if the application code in that container hasn't changed, so it doesn't theoretically it doesn't need to be updated. Probably its dependencies have new versions and updates. So you want to like take it down and get everything updated and redeployed.
So you've got a feature and you've released a feature, and that feature's current for the next 6 months, but you still need a process of weekly, fortnightly, monthly, taking that down, updating it, pushing new versions, doing all the testing cycles. Is that just a new process people need to adopt if it's not something they've done before?
Part of it's automated testing. Like you don't want to be doing this manually. Like if you're still doing a lot of manual testing, I mean I understand like you probably have manual smoke test, does this look right? But you want all your testing to be as automated as possible, and you want as much as you can get away with. There's a trade-off because sometimes your test suite takes forever to run. You don't want that, but you want enough testing to be fairly sure that what you're about to deploy isn't going to break. And you also want the ability, like, hey, if it breaks, I need to be able to quickly react to that and update it and get it fixed.
So we really come back to what some people have called DevSecOps, but really is just developers should be writing their own tests. That there's fundamentally a flaw in some organizations where you don't have developers seeing ownership of the software they're writing, and they can throw it over the wall to someone else. And you need to change that before you can have a successful testing strategy.
But I feel like there's like a personality issue here because, and I think I'm sure I remember reading this about Google, in that the people that release new things, they like working on new things. And so once it's been released, they tend to then request to move to another team so they can work on something else that's new and cool and exciting. You're right, Stephen. This is where DevSecOps came because most people don't have a passion for security. You've got DevPerfOps or whatever the new brand is now for performance testing and operational testing. You have a whole team that is part of that testing cycle.
I think there's a big difference between having a team that's doing the entirety of that work and a team that includes SMEs that are really good at that thing. And what those SMEs are doing is walking amongst the other teams virtually, maybe, and giving people a little nudge, tap on the shoulder, and say, hey, remember to include the security updates. Tap, tap. Remember to actually update your dependencies. Tap, tap. Remember to include some automated tests in this container. And just keeping that level of awareness up there. So they may not be doing all of the work. It's not like the teams write no tests and just throw them over the wall to this team who handles everything that's not the code path itself.
What exactly your point there is that DevOps is not about everybody needing to know everything. It's about the different teams and skill sets coming together and talking to each other.
Back to communication. Time and time again, every business problem is a communication problem.
I mentioned earlier there was 3 things we did at Chainguard to provide images with 0 vulnerabilities. And I mentioned 2, and you're all thinking, well, what was the third one? I didn't forget. So, like the the first one is we build minimal images. The second one is we keep things up to date very aggressively. The third one is because we're our own distribution, or we have our own distribution, we can issue security advisories. So we can say, hey, actually, this CVE isn't relevant to us because we've patched it, or actually, this CVE isn't relevant to us because it actually is about a completely different thing that's not present in our image. Or we can even say, yes, this is a problem, we're working on it.
I've seen a lot of talk around the actual exploitability of vulnerabilities rather than just looking at your vulnerability scanners and seeing the results from that, actually seeing what can people actually hit, what can people actually exploit.
Now, there's a big problem. There's several big problems in the security industry around CVEs. One of them, and a correct complaint, is that the majority of CVEs are just not exploitable. And so the question is, which CVEs should you be more worried about? And there's sort of been two approaches to that. There's the CVSS, which tries to score things and say this is a critical one, which kind of works. But there's also, as you mentioned, the EPSS. But the idea is it gives you an idea of whether or not people have seen this used in the wild, or the likelihood of somebody actually being able to exploit this vulnerability. Which is great information to have, and I hope we see more sort of tools and advice around exactly this point of trying to figure out if a vulnerability is important to you or not.
So it's all about context ultimately. You don't just want to look at a list of 1,000 different vulnerabilities and say we can't use software anymore. It's all bad. But you've got to actually find context and see where that applies to you as an organization.
Yeah, exactly. And hopefully Chainguard helps a lot here by trying to cut down on the number of CVEs you're looking at, and therefore saving you a lot of that work.
Yeah, it's something we did here at Softdyne as well to become an authority that can issue those warnings. It really helps to provide up-to-date information to your customers. And if you are a company doing software updates, the ability to explain the situation to your customers is really valuable.
I mentioned before, and I mentioned this in a lot of my talks, but keeping stuff up to date probably is key. And that's, it's hard work. But it sounds easy, it's hard work, but please try and do it. Please do check out Chainguard images. Possibly they can save you a lot of work and a lot of toil trying to address CVEs.
And a lot of those Chainguard images, they are open source. They are free to use. The Wolfie images and stuff. So it's not like people need to have a commercial engagement. Is that correct?
At Chainguard, we have free developer tier images. So the latest and latest dev versions are totally free to use. If you need older images, or you need images with things like FIPS, then that's a talk to sales thing.
But people can get started today with some free images, testing it out, see how easy it is to put those into production and get those up and running, and then talk to your sales team.
Yeah, exactly.
It's been great talking to you today, Adrian. Thank you very much for your time. If you're watching us on YouTube, don't forget to like and subscribe. If you're listening to us on a podcast somewhere, again, subscribe. Feel free to add comments, questions, anything. We love to get your feedback. That's all for us this week. Thanks, folks.
Thanks, Adrian. Thanks,
Thank you.
listeners.